Hi, I've been giving away tons of oscilloscopes thanks to Keysight. I assumed everyone knows what they are watching my videos, but then I have my friends asking, hey, what were you showing in that clip? Oh, see, I showed on my oscilloscope that... On your what? Huh? You know, that screen with the wiggly... Huh? Why do you even watch my videos then? Your pants were on fire, man! So I'm here to show you what an oscilloscope, or scope for short, is. You have probably seen one of these called a multimeter. This one measures resistance, diode stuff, continuity, capacitance, inductance, transistor stuff, temperature, current, frequency counter, voltage. I guess that's it. And you can get one of these for around $50. In contrast, an oscilloscope measures voltage. Yeah, that's it. And you can get one for a few hundreds or thousands of dollars. Now, if you find yourself saying that, wow, that's a no-brainer, I'll get one of these that does much more for less, then go ahead and slap yourself across the face on both cheeks. Of course, a multimeter is a very useful device that among its functions can measure DC and AC RMS for voltage and current. But this can single-handedly show you the deepest secrets of electronics. It teaches you electronics like nothing else can. It shows you how every component works. You can see every single electron. Well, not that far, but you get the idea. The amount of information and insight this thing provides by only measuring voltage is incredible. That's why, thanks to Keysight, I'll give away 6 more of these babies at the end. I think they've helped me give away around 50 scopes so far, and that's on top of their Keysight Wave event they hold every year. Come on, I said fiscal year. They are giving away over 100 pieces of different test gear every single weekday from March 2nd to 13th. So don't miss this. They gave me a link to use in the description that not only you enter for my giveaway, but also instead of 1, you get 2 entries to their giveaway draw. So if you really like to learn electronics, you need this chance. And it's free. I said fiscal. Now let me show you what it does. Using a probe, it measures the voltage between 2 points, like across a battery, between the scope ground, which is this clip, and the tip of the probe. The signal then travels through a coaxial cable to what's typically a BNC connector that plugs into the scope. The tip of the probe can be this clip that you can grab a wire with, like this. Or you can remove it and use this tip to probe different spots of the circuit. This ring around the tip is ground, so you can also remove this wire and put this special thing on. And using this, you can probe across a very short distance. This shrinks this loop that significantly reduces the electromagnetic noise picked up by your probe in your measurements. Imagine if the voltage was changing in time and you could measure it every second. You could plot a change of voltage in time and understand the behavior of the circuit. And that's what a typical scope does. It plots the voltage change in time. And not just every 1 second, it can be every nanosecond. These things can be incredibly fast, like this one is 2 gigasamples per second. The vertical axis is the voltage level. You can adjust its scale using a knob. And the horizontal axis is for time that you can adjust its scale using the other knob. This can tell you tons about what you're measuring. For example, if I measure the outlet voltage... Ow. Never handle live voltage. I'm a professional. I didn't know with this wire which one was live, but I just figured it out. And this one is the live wire. See, the scope ground is connected to earth through the power cord that is eventually shorted to the neutral. So if I accidentally connect the scope ground to the live wire, I short the power lines. There is a simple solution like this adapter that we can use to bypass the earth prong that is the scope ground. This way I can connect the scope ground even to live wire and probe the other line. And it wouldn't make any difference because it's a sine wave. Now you would think the sine wave would look clean, but not quite. It is a bit distorted due to the uneven current draw from all the instruments plugged into it, especially this flattened area on the peaks that is an effect of all the full bridge rectifiers plugged into the power lines. The circuit looks like this. Let me explain. Ow! Oh man, making the scope ground floating and connecting into live wire means that all the exposed scope grounds like these BNC connectors are now exposed live wires that can shock you. I guess connecting the scope to earth is safer. But then I remember in some countries like Japan, they don't even have earth on their outlets. Actually, let me conclude by the fact that they use the same North American plugs without the ground at 100 volt AC. Sounds like the bare minimum. How do they make sure these exposed grounds are not accidentally live wires? I guess they could use isolating transformers, but very inconvenient. Leave a comment if you know. Anyway, here we have a full bridge rectifier and two probes. One to measure the input and the other one to measure the output. God damn it! Like I said earlier, a scope has a single ground, and so all the probe grounds are shorted together. So you cannot probe across 2 points of the circuit with one probe and across two completely different points with another probe, because the grounds will short them together. And that's where differential probes like this come in. They isolate between the scope ground and the 2 points they are connected to. So you can measure between any 2 points in the circuit regardless of where the ground is. This one is a bit too big because it's high voltage. There are fancy low voltage differential probes too. And unlike these ones, differential probes are not passive and need to be powered. And the fancy ones are powered through the fancy scope connectors. So here's how I will probe the rectifier circuit. One passive probe across the power lines, another passive probe across a shunt resistor to check the current going through the power lines, and one differential probe to check the output voltage. Of course I can do this because I have a 4-channel scope rather than 2. Here's the circuit. Let's see if it blows up first. Okay. Oh, look at that. My resistor is lighting up like a lamp. Well, I guess I could use a lamp as the load. Okay, the circuit is all probed up and I'm using a light as the load. There. You see, yellow is the input line voltage, the light blue is the ripply output DC voltage, and the spiky green is the current draw from the power lines. You see, the rectifier circuit only draws current from the power line and loads it at the peaks of the sine wave, and that's why it distorts the AC sine wave and makes it flat at the top like I showed. Finally probed something. So there, things you can see with a scope, and these are just some of the basic functions of a typical scope. These digital storage scopes take it to a whole other level. This supposedly entry-level scope is higher end than anything I've ever had. See, this scope has its own 20 MHz function generator that can create many different waveforms, and the scope can use this function to find out the frequency response of your analog circuit. Here I have a simple RC circuit wired up to the scope and I run the analysis. The scope sweeps the frequency input and looks at the output voltage level and plots the frequency response of the circuit. Here blue is the magnitude and pink is the phase. You can use this information to analyze your circuit, like calculate the capacitance, or find parasitic components in your circuits, find usable frequencies, or compensate your circuits properly, or adjust your gains as you wish. So what I'm saying is that a good oscilloscope can change your electronic life. Now here's a lightning round of information. A scope can measure up to its maximum frequency accurately, and also up to the frequency band of its probe written on it. So if you use a low frequency probe on a high frequency scope or vice versa, the lower frequency band is your limit and the higher one is wasted. A passive probe has a 1 time or 10 times attenuation switch. 1 time gives you a larger signal, but 10 times attenuation has a higher bandwidth that helps you get the full band of the probe and more accurate representation of signal. Awesome! For proper probe frequency response on 10 times attenuation, you have to probe scope's reference signal, and using the provided screwdriver, adjust the probe filtering circuit to get square waves. Otherwise, wasted. If you don't have a differential probe, you can use 2 probes to measure both sides of your component, and then subtract them in math function to get the voltage across the component, or other math functions. The trigger function is essential to keep a steady oscillating waveform on the screen, because the scope will always start plotting the wave when the wave hits a certain voltage. Otherwise, the signal will look like shit Use acquire function to see your wave normal, peak detect, or average or high resolution to clean it up. Beauty! Really, the life of an electrical engineer or hobbyist would be wasted without a scope. It would be extremely hard and very time consuming to design and troubleshoot a circuit. For us, this is the gateway to heaven. No scope is like no phone and internet and trying to contact your friends to throw a party. It's like dark ages. And there are tons more you can do with a digital scope. Like this Keysight one also has a large capture memory so you can have a good zoom function. It has a built-in digital voltmeter, digital and analog bus analysis and more. I know scopes are more expensive than many of us can afford. That's why Keysight Wave Event is a super great chance to get a great tool for free. And that's on top of the 6 scopes I'll give away. 1 goes to a school, 2 to my patrons at patreon.com, and 3 to the viewers.
Giveaway time!
Just sign up from my link in the description and you'll be in my draw of 3 scopes for the viewers, as well as Keysight Waves draw for over 100 more tools. Patrons are always automatically in their draw and they can ask me questions and stuff. And schools can enter from another link in the description. My link is different in that it gives you 2 entries to Keysight's draw compared to their regular link, so use it. Every weekday during their event, they give away 5 of these and 5 digital multimeters. And then Monday to Thursday, they give away one of the even fancier equipments worth up to $15,000. And on Fridays, they give God Almighty of all equipments worth up to $50,000. And if that's not enough, they'll give away 5 more tools when their YouTube channel Keysight Labs, that provides great information around test gears, hits 100,000 subscribers. I don't know, man. I hope they can keep this up. It's like Christmas for electronics. Good luck to everyone.